Here's a problem worked out. It's number 87 from our Chapter 15 homework. So I'm going to focus on the first one, but I am going to work it down below here from an email. Determine the hydroxide, pH, and pOH of a 0.23 molar ammonia solution. So ammonia is NH3. It is a weak base, therefore it will have a Kb value. When placed into water, it acts as a base, and therefore water will act as an acid. The Bronsted-Lowry theory says bases are proton acceptors and acids are proton donors. When ammonia accepts a proton, it forms its conjugate acid, called ammonium, and when water donates a proton, it forms its conjugate base, called hydroxide. The hydroxide ion is what's measured with something called the pOH, the negative log of hydroxide concentration. What we also need to know, we need to know the value of Kb. Kb is a constant for ammonia, and I opened up my chemistry book and found its value to be 1.8 times 10 to the negative fifth. Perhaps they gave that to you in the problem and it just didn't appear in here. Otherwise, I had to use a chart and find it. But ammonia's Kb constant, 1.8 times 10 to the negative fifth. The other thing we know is the 0.23 molar concentration of ammonia. So what we don't know is the value of ammonium and the value of hydroxide, and the water, of course, drops out of the Kb. Let's call the value of ammonium x and the value of hydroxide as well as x. And we'll just set up an equilibrium using our looked up value of Kb. Kb given as 1.8 times 10 to the negative fifth, set equal to products over reactant where the water drops out. X times x, I'll just write that as x squared. Set over the value of 0.23. Let's find the value of x, knowing that that represents the concentration of hydroxide. So we're going to hit on our calculator, Kb, 1.8 e negative 5 times 0.23, and that value is of x squared, so we'll square root that answer and find for the value of x 0.002 molar. So the concentration of hydroxide, one of the first things we were asked for, 0.002 molar. Negative log of 0.002 molar gets us something called the pOH, since we're negative logging the concentration of hydroxide. So negative log that answer, and the pOH value is 2.69, carrying 2 decimal places, 2.69, the pOH. And then pH is found by taking 14 minus 2.69. 14 minus our answer gives us a pH of 11.31 units. Again, it might need to round a little bit to find how it will fit into your Mastering Chemistry program. I'm not sure how many sig figs they asked you for. So again, to repeat, we set the Kb value, a looked up constant for ammonia, set equal to x squared over 0.23, letting x stand for the concentration of hydroxide. Negative log that value, found something called pOH, and using relationship of pH to pOH, we can easily flip one into the other.